So this video is some key vocabulary. These words should already be in your notebook, and you are just going to put the definition in your own words so that you have these to study with. We're going to start with star. A star is a natural luminous body visible in the sky, especially at night. For example, the sun, Polaris, and Proxima Centauri. Next word is nebula. Nebula is a large cloud of dust and gas in space that sometimes forms stars. The stellar nursery is an area of outer space within a dense nebula in which gas and dust are contracting, resulting in the formation of new stars. A protostar is a contracting cloud of gas and dust with enough mass to form a star. It is the earliest phase of a star's life. A galaxy is a system of millions or billions of stars together with gas and dust held together by gravitational attraction. The Milky Way is a large spiral galaxy that is home to our Sun, Earth, and the rest of our solar system, and about 1 trillion stars.
That's the Big Dipper. That's just a satellite. I don't know what that is. Dear Tim and Moby, how many stars are in the Milky Way? From Buzz. A lot. Okay. There are somewhere between 200 billion and 400 billion stars in the Milky Way galaxy. Our Sun is just one of those many stars. The Milky Way is made up of planets, gas and dust, and an unknown substance we call dark matter. From Earth, the galaxy looks hazy and white in the night sky, like milk. That's why it's called the Milky Way. But if we could step outside our galaxy and look in, the Milky Way would look like a spiral with a band across the middle. This pattern of galaxy is called a barred spiral. Its center contains a bulge of stars. 4 major arms, and several minor ones, spiral around the bulge in an area known as the disk. Outside the disk is a spherical halo of old stars. Most astronomers think there's a supermassive black hole at the center of the galaxy. A black hole is the result of a collapsed star. Its gravity is so strong that not even light can escape it. A supermassive black hole is much bigger, caused by the collapse of a bunch of stars. One of these at the center of the Milky Way would help explain why its arms keep rotating around its center. The Earth is located in a minor arm of the disk called the Orion Arm. Our solar system orbits around the galactic center once every 225 to 250 million years. That period of time is called a galactic year. That's the star you come from? You have a home planet? Really? Huh. What's it called? Yes, that's very sad that you can no longer remember your origins and your people, along with your planet's name. You're messing with me, aren't you? Aren't you?
A galaxy with a bulge in the middle and arms that spiral outward in a pinwheel pattern is called a spiral galaxy. An elliptical galaxy is shaped like a round or flattened ball and generally contains old stars. The universe is all of space and everything in it. A planet is a large body in space that orbits a star and does not produce light of its own. The Hertzsprung-Russell diagram is a graph relating the surface temperatures and absolute brightness of stars. A black hole is a place in space where gravity pulls so much that even light cannot get out. The gravity is so strong because matter has been squeezed into a tiny space. Apparent magnitude is the brightness of a star based on the location of the observer. For example, stars that are closer but fainter appear brighter in the night sky. Absolute magnitude is the measurement of the brightness of a star. It is based on the amount of energy it emits from its surface, and it depends on the size and temperature of the star. So apparent magnitude is how bright it looks. Absolute magnitude is how bright it actually is. Luminosity is a measure of brightness of a star. A main sequence star is a star that is fusing hydrogen atoms to form helium atoms in its core. Most of the stars in the universe are main sequence stars. A supernova is a powerful and luminous stellar explosion, and it occurs during the last evolutionary stages of a massive star.
From Corey. This is one of my favorite topics. Stars change throughout their lives just like we do, only they live for billions of years instead of a few decades. They start out as clouds of gas and dust called stellar nurseries. The force of gravity slowly pulls particles inside these clouds closer together, causing dense clumps to form. If a clump grows large enough, the pressure caused by gravity inside one of these baby protostars begins to generate heat. This heat and pressure build until nuclear fusion reactions begin to take place in the core. Gravity pulls hydrogen atoms together, smashing and fusing them into heavier helium atoms. Nuclear fusion generates an enormous amount of energy, causing the star to ignite. This is the beginning of the longest part of the star's lifetime, or its main sequence. That's where our star, the Sun, is right now. It's about 4.6 billion years old, which means it's a little less than halfway through its 10 billion year long main sequence. Well, what happens to a star after its main sequence depends on its mass. Astronomers actually don't know what happens to low-mass stars, those with less than about half the mass of our Sun. They may actually have a main sequence that lasts more than 1 trillion years. That's longer than the current age of the universe. Mid-sized stars, like our Sun, become white dwarfs. Those are super dense objects, about as massive as the Sun, but only a fraction as big. They're around the size of the Earth, actually. A couple of things will happen before the Sun turns into a white dwarf, though. The Sun will begin to die when it uses up all the hydrogen in its core. At that point, the Sun will expand, ballooning to many times its current size. Stars in this stage of their life are called red giants because their surfaces cool down to a red glow. Plus, they're really, really big. The Sun will start burning helium at that stage, fusing it into even heavier elements. Eventually, it may get so big that it engulfs the Earth. Oh, don't worry, we'll all be long gone before that happens. It's billions of years away. Anyway, after no more than about 1 billion years as a huge red giant, the Sun will begin to collapse under the pressure of gravity. It'll actually get kind of unstable, expanding and contracting and shedding its outer layers in the process. The remains of those outer layers form a big cloud of gas and dust called a planetary nebula. Nope, they don't have anything to do with planets. They're just called that. But you know, you've probably seen some awesome pictures of planetary nebulas from the Hubble Space Telescope. These are pictures of stars that are at the end stages of their lives. It's kind of like watching what will happen to our Sun way before it actually does. Anyway, At the center of a planetary nebula is a core of carbon, which, after cooling, finally becomes a white dwarf. Well, that's the route our sun will take, but it's not the only way a star can die. Stars much bigger than our sun collapse so quickly that they explode into a supernova, scattering stellar material far and wide. A supernova explosion can last for a month or longer, and during that time it can be as bright as a galaxy with 1 billion stars. The clouds of gas and dust that supernovas spew out are where heavy elements are made, and they lead to the formation of new stars. The core that's left over can go one of two ways, depending on the mass of the original star. If the star is about 10 times as massive as our sun, the protons and electrons in the core are crushed into neutrons. What you get is a neutron star. Some neutron stars spin rapidly, emitting pulses of radio waves. These are known as pulsars. If, on the other hand, the original star was more than 10 times as massive as the sun, its supernova core will collapse in on itself. It will keep collapsing until it forms a tiny area of infinite density called a singularity. We call this a black hole, and its gravity is so powerful that nothing within range can escape it. Nope, not even light. And nothing you throw into a black hole will ever come back. We actually have a whole other movie on those, so you should go check it out. Well, time to take the trash out. You know, we could just take the trash out to the corner.
The life cycle of a low-mass star starts off as a protostar, goes to main sequence, to red giant, to a helium-burning star, which leads to a double shell burning red giant, a planetary nebula, and a white dwarf. So protostar, main sequence, red giant, nebula, white dwarf. For a high-mass star, we start off with a protostar. That leads to a blue main sequence star, a red supergiant, a supernova, and then eventually a neutron star or a black hole.